Hi, today's lesson is on the tangent line. So we're going to talk about the tangent line problem, and this kind of flows from what we've been doing with limits. So what is a tangent line? A tangent line of a curve is a line that touches just at one point. So if I was looking at a graph, we could have a tangent line that touches the curve just at that one point. So what that tangent line does is it approximates the slope of the graph at that point. Okay, so you'll notice at different points, say I was over here, my tangent line would have a different slope. Okay, so you would have a different tangent at different points along your curve. Okay, so this leads into derivatives, which is really a big connection into calc. So the derivative of a function, the derivative is really another way to find slope. And the derivative is actually defined through limits. So when you are doing your derivative, you're actually going to be taking the limit. And it's the limit as h goes to 0 of f of x plus h minus f of x all over h. And so that's how your book defines it. And different books define it with a different variable other than h, but they work exactly the same. So this is your limit definition of a derivative. Well, if you notice, you had problems on previous assignments on limits that had you find these, but they didn't actually define it. So you have a problem that's like this. It says given f of 3 is 4, and the derivative, so this is the notation for a derivative, f prime of 3 is negative 2. It says, what is the slope of f at that point? Well, again, what did we talk about with the derivative? Derivative is a fancy word for slope. So our slope at that point would just be negative 2. So let's go on. What if they give you a picture and we want to approximate the slope at that curve? Well, we're trying to approximate. So if we're looking here, here is our tangent line that is in red. If we want to talk about slope here, we're really going down 4 and over 2. So down 4 over 2. If we approximate our slope, our approximate slope of that tangent line then would be negative 2. And you could do that at any point on that line. You're just trying to guess, get an approximate value of that. So now we have to actually use that definition that I gave you earlier to find the slope of the graph of the function at that point. So we're going to start, we're going to write out our definition. So the limit as h goes to 0 of f of x plus h minus f of x all over h. So the first thing that you really want to find, and I'm going to put it over here, is f of x plus h. So we're going to do a little algebra and figure this out. So wherever I see an x, I'm going to replace it with x plus h. So I would have something that looks like that. So now I have to simplify it. So what is that going to be equal to? I'd have 3x plus 3h. Now we have to simplify x plus h. So x plus h quantity squared, which is really x squared plus 2xh plus h squared. So I'm kind of running out of room squishing it together, but we can distribute, give myself a little more room. So I'd have 3x plus 3h minus 2x squared minus 4, sorry about that, xh minus 2h squared. So really what this is the value that we're going to plug in for that part of the formula. So we're going to say the limit as h goes to 0 of, we're going to put 3x plus 3h minus 2x squared minus 4xh minus 2h squared minus my function. Well, what we have to be careful of is we are switching our signs on both pieces. So I'd have minus 3x and a plus 2x squared all over h. Now, as we're doing this, what you will notice is my 3x and negative 3x will cancel. My negative 2x squared and my 2x squared will cancel. So what I tell my calc students is everything at the end should cancel out. If it doesn't, then you'll have a mistake. And if you would not have distributed that negative, you would have a problem there. So now let's take out what we have left. So we'd have the limit as h goes to 0. Now we're really dividing out this h. So we'd have 3 minus 4x minus 2h. And we're taking the limit as x goes to 0. So what you'll see here is that last term would be negative 2 times 0. So if we did that direct substitution, we would have 3 minus 4x. So that would be what is called the derivative. Okay, that is the slope of that graph at any particular point. Now, if I want the specific point that is given, I just need to plug in my x value. So my slope would be 3 minus 4 times 3, which is 3 minus 12, which would give me a negative 9. And so again, that is my derivative or my slope at the value of 3. If you need help or you need anything to prepare for your final, please let me know. I will be happy to help you. Have a great day.